Myself, Rishita. In this video, I'm going to give presentation and demo on exploring Airbnb data using Firebase emulation basis system. The objective of this project is to build an emulated distribution file system and to implement partition-based map and reduce and data stored in EDFS to perform search operations, and to implement a navigate function to show the direction, directories, files, and an explanation facility to show the users how the search results were obtained. So in order to do this, execute this task, I have taken Airbnb data. So Airbnb is an online platform for the temporary housing, rental, and hotel industry. So this dataset contains the information of the Airbnb in New York, Boston, Seattle, and Los Angeles cities. So the original dataset consists of 75 attributes, out of which I have taken only 6 attributes in order to perform search and operation. So the attributes including ID, host ID, superhost, price, review rate, and city. Superhost on Airbnb means hosts who have good experience, high ratings, and showed good hospitality towards guests. So in order to implement task 1, I'm using Firebase emulation system, and I have created 2 JSON objects, data node and name node, where name node stores the locations of the partitions of a file, whereas data node stores the actual data. So this is how the data node and name node will be in my Firebase. And I have implemented task1 commands, mkdir, which creates a directory in file system, ls, which lists the files in a given directory, cat, which displays the content of a file, remove, remove a file from the file system, put, it uploads the file into the file system. And before uploading the file into the file system, I'm dividing the data set into k partitions by rows before uploading the data into Firebase. So I'm giving the user to give the input. So how many partitions the user want to do for this data set. And I'm also defining methods like get partition locations, which will return the locations of partitions of the file, and read partition, which will return the content of partitions of the specified file. And this is how data node and name node objects will look after uploading the Airbnb dataset into the Firebase. So and I have implemented partition-based map and reduce on data stored in Firebase, and I have used read partition in order to get each partition data. And I have defined 3 functions in order to complete this task: map partition, combine, and reduce. So, this is a flowchart how map, combine, and reduce works. So this is the input file. So here the input is divided into 3 partitions, where map partition will take the input from each partition and do the map, whereas a combine acts as the local reduce function, where it will combine the data and produces the output, where reduce function will take the output from each combine function and produces the final output. Here the combine function reduces the computations of reduce function. And I defined a function named search in order to perform search operations among cities. I defined minimum, maximum, add, count, average functions in order to do above search operations. So that combine and reduce functions use those functions in order to perform search operations. So I'm using Jupyter user interface to support the EDFS commands as described in task 1, and defined navigate function in order to see the directories and files of name node and data node, and made it an user interactive to select between name node and data node using interactive controllers in Jupyter Notebook. And I'm using search file name command in order to search data based on the instructions given. So now I'm going to give the demo how I implemented these tasks. So basically, this is the Firebase. This is my Firebase where there are 2 JSON objects. One is data node and another one is name node. So this is my core. So these are the functions. And this is the mkdir function which makes a directory. And this is the ls function which displays the files in a particular directory. And this is the metadata function in order to store and update the metadata. And this is the put function to put the partitions in Firebase. And this is get partition location function to get partition location. And this is the read partition in order to return the content of partitions of the specified file. This is the rm function which removes the file in Firebase. This is the function to display the content of a file, cat function. And map partition function, it performs a mapping by taking the each partition as the input. And I'm defining the add, count, maximum, minimum, average, combine, reduce functions in order to perform combine and reduce in order to perform search operation. So basically, this is my search function. So I'm defining some search operations for my Airbnb data. So this is the search operation. And Firebase and navigate functions are in order to show the directories and files in my Airbnb data. So I have defined a switch function in order to execute the command. So this is where I will give the input. So when I run this code, it will ask me to enter the command. So I want to show, I will first I want to make a directory, user Rishita, which will make the directory in the data node and meta node. Sorry, data node and name node. Now I want to put the Airbnb data in the given directory. So it is asking me to enter the enter number of partitions. I'm entering 5. Here we can see the data is uploaded. So in data node, it is storing the data of the each partition of the file. And in name node, it is storing the each partition location of the data. Now I want to see what are the files in this directory, user Rishita. So it will ls function will returns the list of the files in the given directory. Now I want to display the content in Airbnb, so I'm using cat command, which will returns the data in the Airbnb.csv. So I am also defined this read partition as a command because I just want to see what this function will do. So read partition Airbnb. I want to read the partition of Airbnb data. So it is asking the enter partition number. So I want to see the partition data of the. This is the actually data in the third partition. I also defined the get partition location as a command. So it will returns the locations of the partitions of this file. So I just define this as a function, defined as a commands because I just want to see what those functions are doing. And now I will show you how the remove command will work. I want to remove this file from this directory. Yeah, so it is removing the file from the directory. Now I want to put it again because I want to perform search operation. Again, I want to put it in, upload the data in 5 partitions. Now I want to, so we'll see whether the data is, yeah, it is updated. So I want to search. So for searching, I just even given the instruction, if you want to search the file, enter command search file name. So user can just use the command search and the file name which you want to search. So in my case, it's airbnb.csv. So I'm putting it that. And it gave me some instructions. So let us read this. So choose the search operations from the following by entering number. So the first one is number of hotels within a price range in each city. And second one is maximum price of a hotel in each city. Third one is minimum price of a hotel in each city. Fourth one is average review rate of hotels in each city. Fifth one is number of superhosts in each city. So if you want to enter exit, enter 0. So if I want to do these search operations, I have to enter their number. So for example, if I want to find the number of hotels within a given price range in each city, I have to enter the number 1. Oh, it is asking me to enter the range of price. So I have to enter. So I just want to see what are the hotels in each city which are in the price range of $100 and $200. Yeah, so it's giving me the output. So there are actually 5 hotels in Los Angeles in a price range of $100 and $200. And there are 6 hotels in Boston. And there are 4 hotels in Seattle. And there are 5 hotels in New York. So I have only taken the sample data of 40 data entries in order to execute this command. So it is giving me these numbers. I also created this one. So if user want to know how this result came, so he can actually use this command. So if you need an explanation, enter 1, else 0. So if a user want to know, so he has to enter 1, which will give the explanation. So in this explanation, it consists of input to the each map partition, and output from map partition, and output from local combine, and the same goes with the each partition. And finally, it also gives the shows the input to reduce function and the final output from reduce function. I will just explain this one. So this is the first input to the map partition 1, where we have to find the hotels which are in this price range. So first I'm using a dictionary to store this map. So I'm storing in the form of key value pairs. So for the first Los Angeles, we only have one data entry. So that is which is in the price range of $100 and $200. So we are adding 1. In Boston, we have 2 data entries here, but we only have one data entry which is in the price range of $100 and $200. So we're adding 1 here. And for Seattle, we have 3 data entries, but only 2 data entries are in the price range of $100 and $200. So we are adding 2 ones here in order to represent that. Same goes with the New York. So for the output from combine, so here the combine function is just adding the number of ones here. So it's just basically counting. The Los Angeles, we only have 1. Boston, we only have 1. But Seattle, we have 2 ones. So it is giving the 2. And New York, it is giving the 1. The same goes with the each partition. Here we can see each partition. So the finally, the reduce function will take the output from each combined function, and it will produces the final output from reduce function. Again, here the reduce function will just add the output from each combined function according to the key values. So basically here, if you don't use the combine function, we have to do everything. You have to count every one and everything in reduce function itself, so which will increase the number of computations if the data is large. So basically combine function is reducing the task. That's why I'm using the local combine function. So it's again asking if I want to choose any search operation. So now I want to find the maximum price of a hotel in each city. So I'm entering 2. So it gives me the output. In Los Angeles, the maximum hotel price range is $179. In Boston, it is $300. In Seattle, it is $362. In New York, it is $169. I want to explain this too. So basically, here this is a input to the map partition 1, and this is from the This is the output from map partition 1. It's just like map the map according to the key, like each city. So key will be the cities and values will be the price. So it will just map according to that. So the keys will be the cities, and just these are the prices uh, which are in, like, the hotel prices in Boston, and these are the hotel prices in Seattle, and these are the hotel prices in New York. So the combined function here locally finds the maximum value in each city. So in Los Angeles, we already have one hotel, so it is just gives the price of that. But in Boston, we have two hotels with two different prices. So among them, 80 and 149, the maximum value is 149. So it is storing the $149. And in Seattle, the maximum price is $362. So it is storing the $362. In New York, it is 123. So it is storing 123 value here. So it basically each combined function in each map partition, in each for each partition, it will store the maximum price of each city. So when it comes to the final reduce function, so basically it takes the output from each combined function and just compare the just to see for each city what is the maximum value from the each combined function. So here we can see the big difference, like it really saves a lot of computation power by using the combined function. So now we will go for the another search operation. Now I want to do minimum, I want to find minimum price of a hotel in each city. For that I have to enter 3. Now I will enter 3. So it will gives me the output of minimum price of a hotel in each city. So in Los Angeles, it is $50. In Boston, the minimum price is $78. In Seattle, it is $87. In New York, it is $55. So minimum price is also works as the maximum price of a hotel in each city. So instead of maximum value, the combine function locally finds the minimum value, and final reduce function also finds the minimum value from each combine, like according to the city, and it will give us the final output as this. So I'm not showing the explanation here because it is same as the uh, maximum price of a hotel in each city. So now I want to perform average review rate of hotels in each city. So for that I have to enter 4. So it will gives me the overall review rate. So for Los Angeles, it is 4.76, and for Boston, it is 4.77, and Seattle, the overall review rate is 4.89, and for New York, it is 4.77. So I need an explanation for this. Okay, so this is the input. So basically, I'm not using the combine function here, and I'm just using the map function here. So which will take the which will just map the uh, each review rate to the key, and final reduce function will take the output from each map partition and will perform the average function. So now finally I want to do the final search operation, which is nothing but number of superhosts in each city, which we are eager to know. Okay, so in Los Angeles, there are 4 superhosts. In Boston, there are 7 superhosts. In Seattle, there are 4 superhosts. In New York, there are 2 superhosts. So I want need an explanation for this. So actually, this is same as the first case. So it is again like it will see in each city, like so in for superhost, it will see whether the host is a true superhost or not. For that, if it is the superhost represents if it is a 2, then it means this host is superhost. So if the superhost value is F, that means like the host is not a superhost. So it will just add 1 according to that. So for Los Angeles, of course, we have a value here, we have a hotel here, but the host is not a superhost. So it is giving me the empty uh, key value pair, because like we don't have a superhost for Los Angeles. So that's why it's giving me the empty list. The same goes for the Boston, Seattle, and New York. Again, here the combine function will do say count the number of ones here and produces the output. And reduce function will take the output from each combine function and sums up the and adds the output of each combined function according to the key values. So these are my search operations. So I'm done with my search operation. So I want to exit from here. So in order to exit, I have to enter 0. So we exited from the search operation. And I have created a navigate function in order to see the directories and files in name node and data node of my Firebase. I'm just running this. So yeah, in name node, I have this directory user. Under that, I have directory Rishita, and under that, I have the Airbnb, under which I have the partition files P1, P2, P3, P4, P5. So it will show me the directories and files in name node. Now I want to see the data node. So I have made it an user interface so that he can choose in between name node and data node. So I want to see data now. I want to see data node. So in data node, I have the user directory again, and under which I have Rishita directory, and under which I have these files Airbnb 0, Airbnb 1, Airbnb 2, Airbnb 3, and Airbnb 4. This is how I'm showing the directories and files in Firebase. So this is all my implementation. Thank you.